We are going to begin section 1.5. The title of this section is called Describe Angle-Pair Relationships. So one good place to start would be to just look over the title and to think about whether we know what all of these things are. So when I say angle, right, we might think of the symbol like this, okay? Or as we've just learned in the previous section, the angle that's connected by two rays at their endpoint, right? This right here has a certain measurement, usually given in degrees. The word pair, if I say I have a pair of, a pair of something, then we know that it's two things, right? And so between the two angles, we're trying to figure out how they might relate to one another. So just to start off with a quick example, what are some of the different types of relationships that we see? So for me in my life, I have several different kinds of relationships. So for example, I have two little girls. The littlest one hair is not quite as long as the older one, right? So I have two little girls, and that relationship would be father-daughter relationship, right? And then I also have a wife at home, and so that would be like a husband and wife relationship. And even with you guys, right? So I'm here, and then you guys are all on a screen, but you're on the Zoom call, right? And that would be a teacher to student relationship. So in the same way, we can look at an angle and how it relates to another angle, and we can give them different types of names. That's kind of our big takeaway for 1.5. To understand that angle pairs, we can look at them, and then we can name them based on the types of relationships that they have. So to begin, the first type of relationship has to do with adding up the angles measurements. And remember, the measurements are given in degrees, right? Such as 45 degrees. And two types of relationships that we see are called complementary and supplementary. So these guys have to do with the relationship between the angles and what they add up to. So when we say that they're complementary, for instance, we would say that the angles add up to 90 degrees. That's what it means for it to be complementary. And then in a similar way, supplementary angles, these angles add up to 180 degrees. Now, from the previous section, we learned that this is a right angle. And then we learned that this would be a straight angle. Okay? So what does that look like in picture form? Well, when complementary, so first and foremost, we can start off with a 90-degree angle, like this. Okay? And then if we were to just cut it down and split it, you see how we form two angles. And if we call this guy angle 1 and we call this guy angle 2, right, then we would say that angle 1 and angle 2 are complementary. Because the measure of angle 1 plus the measure of angle 2 equals 90 degrees. Okay? So just a very simple example here. So if we're given a right angle, oops, I'll erase that. Okay, and they tell us, oh, this right here is x, and this right here is 2x. Okay, and they say that they are complementary. Find x. right? Then we would say that, well, these two angles have to add up to 90. So once again, measure of angle 1 plus measure of angle 2 equals 90 degrees. So x plus 2x equals 90. Then we can go ahead and do some math, some algebra here. So x and 2x become 3x, which equals 90. We can divide both sides by 3, and then we're left with x equals 30. And so just to verify, when we put x equals 30 into here, this is 30. And then when we put 2 times 30 into here, because that's what x is equal to, right? So we're just double checking our answer. 2 times 30, that's equal to 60. So if one angle is 30 degrees and one angle is 60 degrees, what do they add up to? 90. And so we have checked our answer. It checks out, and so that looks like a correct answer for us. The second one, for supplementary angles, they do have to add up to be a straight angle, meaning, right, a straight line like that. And then you can have any two angles that are split up in that way. And once again, if we call one angle 1 and we call one angle 2, then we would say that angle 1 and angle 2 are supplementary. Or in other words, measure of angle 1 plus the measure of angle 2 has to equal to 180 degrees. Okay, and just another example that we can give. If they say that this is 70 degrees, and then they say find all other angles. Right? And we'll call this guy x. So one thing we can see is that 70 and x form a straight angle. So from there, we can subtract 70 and subtract 70, and then we get x equals 110. So this equals 110 degrees, okay? And then from there, we can find y, because the 110 and the y, they form another straight angle. So 110 plus y equals 180. Subtract 110, subtract 110, and so y equals 70. So this right here is 70 degrees. And then we already did this one because we did it right here. So 70 and 110 would be this guy as well. And so there are all the other angles, okay? Now, one way you can remember this, if you struggle with like, oh, which one was complementary, which one was supplementary, the complementary starts with the letter C, which comes alphabetically, comes first before supplementary. So you could think about how, you know, the complementary goes with the smaller one, which is 90, and supplementary goes with the bigger one, which is 180. Or you can also think of supplementary and straight, right? Supplementary angles form a straight line. And in that case, you know, we would know that that would be 180 degrees, okay? All right, so that's the first type of relationship. And then just one more relationship that's presented to us in this section is the relationship of a linear pair and vertical angles. So these don't have so much to do with what the angles add up to, but it is a different type of relationship that we see. I want you to notice here, when it says linear pair, to notice the word that's inside linear. It's the word line. And then once again, that pair shows up again. So it's like a pair of angles. So if I say angle A and angle B are a linear pair, all that I'm saying is that angle A and angle B, they form a line. So angle A and angle B form a line. That's all it means to be a linear pair. And so you might wonder, wait a minute, this looks very familiar. Isn't this the same thing as supplementary? And in one sense, it is the same, right? You would say, yeah, like every linear pair are supplementary angles. But in another sense, they're different, because for supplementary, we're talking about, well, without getting too complicated, for supplementary, we're talking about their angle measurements equaling 180. And then with A and B, we're saying that they form a line together. They're a linear pair. So we're not so much concerned with their measurements, but we're just concerned with the fact that they form a line, Okay, so that might be a little bit vague. It's like it might still feel like what's the difference, and in some ways it is more like a semantic argument, or just arguing about like what exactly the differences are. But like the answer to this would just be that with supplementary, okay, we're concerned with angles, with angles measurements, whereas with linear pair, I think we're concerned more with the pair of angles themselves. And not the measurements. But in essence, they are the same. But you just have to be able to see something like this, and then if you read in a problem, angle A and B form a linear pair, and they never mention supplementary, then you would have to know just by looking at that term that, okay, this means that they're supplementary. You see what I mean? So, yeah, so hopefully that's helpful. And then just the last thing here is the vertical angles. This is one of the biggest, most important things that will go with you beyond this chapter. It will go with you everywhere. And thankfully, vertical angles are really easy. And here's what I wanted to say about vertical angles. This is a one rule that you always have to remember no matter what. Vertical angles are always congruent. Okay, they always have the same measurement, no matter what. And how do you make a vertical angle? So to make a vertical angle, you have to make sure that two lines intersect in a point like this, okay? And then vertical angles are always right across from each other, like that. Okay, so wherever they intersect, right, there's vertical angles here, vertical angles there, okay? No matter whether it's acute, obtuse, right, the vertical angles are always right across each other. And so if I can just give a quick example here, like let's say we were to see something like this. And you know what? I'm going to erase one of these guys just to make a little bit more room. All right, so let's say we were to see an example like this. Okay, so we see a bunch of lines that intersect each other. And let's say we want to figure out which angles are congruent to each other, which angles are the same. Well, one thing we can do is we can look at all the vertical angles first. So you know that this angle has to be congruent with this angle. Okay? And then you know that this angle, so notice I've marked it with two curves instead of just one, has to be congruent to this angle. Okay, vertical angles they're right across from each other. And then this angle, and I'll mark this one with a little line like that, has to be congruent to this angle. And in the same way, this angle has to be congruent to this angle. And then we can kind of see the pattern here. So if I just do 3 here, they have to be the same. And if I do 3 here, we know that these guys have to be the same. And then finally, if I just do 4 here, these have to be the same as that. And then we know that 1, 2, 3, 4 has to be the same as 1, 2, 3, and okay. So it's a really fun thing to know that vertical angles are congruent because it tells you a lot about the other angles that are right across from it. It tells you that they're exactly the same. Okay? For the example problem that I wanted to do is from page 39, number 31. And I'll go ahead and just draw that one. So it says this, that there is a pair of intersecting lines like this. And so already when you look at it, you might think, oh, I see some vertical angles, I see some linear pairs, I see supplementary. But then here's the deal. It tells you that it's 7x degrees. it tells you that it's 2y degrees, and then it tells you that it's 9x plus 20 degrees. Okay, so there's a lot of ways to solve this problem, but there's only one first step that we can see. So we have to check a couple of things. First thing, vertical angles. And we know that they are always congruent, right? So that means that when the vertical angles, we could set them equal to each other. But when we look at 7x and 2y, and we say, okay, 7x has to equal 2y, this is not helpful for us right now because we have too many letters to work with, right? So we want to look for a different kind of relationship. And so we kind of scan our board a little bit, and you might notice that the 7x and the 9x plus 20, they form a line, right? So they form a linear pair, which we know this means that they add up to 180 degrees, which means that they are supplementary, because supplementary straight. Okay, and so right there we can set up an equation, 7x plus 9x plus 20 equals 180 degrees. And then from there, this just becomes an algebra problem. So 7x plus 9x, which is 16x, plus 20 equals 180. And then from there, we can work out the rest of it. So we can subtract 20 from one side, subtract 20 from the other side. We're left with 16x equals 160. And then from there, we can divide by 16, and then divide by 16, and then we're left with x equals 10. So then if x equals 10, I know that this has to equal to 7 times 10, which means that this is equal to 70 degrees. And if I know that this angle is 70 degrees, then I know that this also has to be 70 degrees. So I can say that 2y degrees is equal to 70 degrees, or 2y equals 70. And then from there, I can just divide out, y equals 35. And just like that, I have my two answers, x equals 10, y equals 35. Okay, so in a nutshell, I mean, we need to know these different types of angle relationships that exist. So first, that two angles, an angle pair can be complementary, meaning they add up to 90 degrees. Secondly, that they can be supplementary, which means that they add up to 180 degrees. And complementary comes first in the alphabet, so it's a smaller number. Supplementary comes second, so it has to be the bigger number. And supplementary and straight, we can remember it that way. Then we can also see that supplementary angles form what we call a linear pair. And linear pair and supplementary is, in essence, the same thing. And then vertical angles are always congruent no matter what. They're always equal to each other. And they're the ones where whenever you see an X that forms, whenever you see two lines intersect each other, the angles that are right across from each other are vertical. And so I've given you guys some indications of that. And then hopefully this problem will give you some help for the